What on the off chance that I told you there was once a star so gigantic, so capable, and so unusual that it had a dark gap interior it? No, this isn't science fiction. It's a genuine possibility from the daybreak of the universe. Nowadays, we're jumping into the riddle of dark gap stars, too known as quasi-stars. What may be a dark gap star? Dark gap stars aren't like anything we see nowadays. They're theoretical objects, gigantic stars that will have existed within the early universe, over 13 billion a long time back. Picture this, a gigantic star, hundreds of thousands of times the mass of our sun, shapes from the thick clouds of hydrogen after the Big Blast. But rather than biting the dust in a commonplace supernova, its center collapses into a dark gap, whereas the external layers keep falling internal. And here's the turn. The dark gap doesn't immediately devastate the star. Instead, the energy from the dark hole's growth disk, the fabric spiraling into it, heats the encompassing gas. This outward pressure holds the star up, for a whereas. A star fueled by a dark gap. Terrifying. And excellent. How do they work? The dark gap interior nourishes on the star's center. Because it eats up mass, it transmits strongly radiation which pushes against the collapsing fabric. This fragile adjust makes a bloated, gleaming, unsteady creature. These quasi-stars can develop to be thousands of times bigger than the sun, but as it were live for many million years, a flicker in cosmic time. Once the adjust breaks, the star collapses totally, clearing out behind enormous dark gap, potentially with tens of thousands of solar-oriented masses. These early dark gap stars may well be the root of the supermassive dark gaps we see nowadays at the centers of worlds. Why haven't we seen one? Well, black hole stars existed at the very starting of the universe, long sometime before systems and planets like soil shaped. Their light would be black out, redshifted, and incredibly difficult to distinguish with current technology. But future telescopes, just like the James Webb Space Telescope and beyond, might catch a glimpse of these ancient titans, giving us clues almost how the primal dark holes and, in the long run, galaxies formed. Wyatt things. Dark gap stars may be the lost link between the first stars and the supermassive dark gaps we see in the universe today. If we can affirm they existed, we'll have a clearer picture of how structure shaped in the early universe, how dark gaps grew so fast, and perhaps even how life-friendly universes like our own came to be. The idea of a star fueled by a dark gap is more than cool. It is a key to our cosmic roots. Much appreciates for watching. If this blew your intellect as much as it did to mine, give it a like, share with a personal space geek, and hit subscribe for more deeper dives into the cosmos. Got questions about black gap stars or space puzzles you want explained? Drop them in the comments below. Stay curious.